Good morning or afternoon or whatever it is where you are. This video and this section are all about the inverses of functions, So we're going to talk about what that is in this video and do an example of it. So first of all, let's suppose we have a function with domain x and range y. In other words, the function takes things in domain x and sends them to things in the range y. So it does so like this. So this is our function little y. Takes the first one, sends it to that point, takes the second point, sends it to this point, and it takes the third point and sends it to this point. Well, what you can see is that this function little y is 1 to 1. Now what 1 to 1 means is that for each of the outputs there is only one input sent there. For each of the outputs, there is only one input sent there. So if, for example, this third one was also sent to the first point, then this would not be a one-to-one function because this output would have two inputs sent to it. All right, so one-to-one function means each output has only one input sent there. Well, what that means is that we can go backwards. So because the function y is one-to-one, we can actually go backwards. We can take this point here and send it to the point it came from. Same with this point here, and same with this point here. So if this is the point x, little x, then this must be the value y of x. Now if we call this backwards thing, this thing that's taking the points and sending them back, if we call that y inverse, then what we can see is that y inverse of y of x is equal to x. And what we have here is actually a function because it still takes one input and sends it to one output. So this backwards function is called y inverse. Y inverse is the function that takes all of the outputs of y and sends them back to the input that they came from. And that function is called y inverse. Notice that we can only do this if the function little y is 1 to 1. We can only do this if the function little y is 1 to 1. Otherwise, suppose that y is not 1 to 1. Let's suppose now that y is not 1 to 1. Here's x, here's y. And suppose, for example, these 2 points are both sent to the same output by little y. Where is y inverse supposed to go? Where is y inverse supposed to go? Y inverse, so suppose this one is x1, this one is x2, and then this is the point y of x1, which is equal to y of x2. What is y inverse of this thing supposed to be? Where does it go? Well, actually it would have to go to both of them if we were going to directly invert this. But then if it did go to both of them, so if it did go to both of these points, it would no longer be a function because then we would be taking this one input and sending it to two outputs. So in this case, y inverse does not exist because y is not 1 to 1. So y needs to be a 1-to-1 function. Each output must only have one input mapped to it, so not in this case. So y inverse does not exist because y is not 1-to-1. Okay, well our beautiful function here is 1-to-1, so y inverse does exist. And also we noted the interesting property that for each little x, there's nothing special about this first one, for each of these little x's we have that y inverse of y of x is equal to x. And that makes sense because y inverse is the function that sends y of x right back to the input little x that it came from. Something also to note, what is the domain of y inverse? So y inverse has domain red x and range red y. So actually the domain of y inverse is the same as the range of x. The domain of y inverse, I better write this down. So let's write it in green. Domain of y inverse is the same as the range of y, because y inverse takes all of the things that have come out of y and sends them back where they came from. So the domain of y inverse is equal to the range of y. That's the first thing to note. And similarly, the range of y inverse equals, well, you guessed it, the domain of y. Because the things that come out of y inverse, must be the things that went into y in the first place. So the domain of y inverse equals the range of y, and the range of y inverse equals the domain of y. Remember those two sentences. All right, let's do a quick example now. Our example will be the following. So let's suppose we have the function y, and it has domain, the real numbers, and it also has a range, the real numbers, and we have the function defined by y of x equals 2x plus 17. In other words, it takes in a real number, multiplies it by 2, and then adds 17 to it. Well, we can find the inverse now. So in this case, we know from algebra that because y of x is equal to 2x plus 17, we must have that 2x is equal to y of x minus 17. And therefore, by dividing both sides by 2, we get that x is equal to y of x minus 17 divided by 2. So if we want to send y of x back to the value x that it came from, what we need to do is first subtract 17 and then divide by 2. That's what we worked out just there. So in other words, whatever goes into our inverse function, we have to subtract 17 from it and divide it by 2, since the inverse function is taking the outputs of y and sending them back to the inputs. In other words, our y inverse function is the function that takes an input, subtracts 17, and divides it by 2. Don't get confused by these two x's. Don't get confused by this x and this x. They are not the same. All the x is a label. All the x is a label for the thing that goes into our function. And what we calculated here is that to invert y of x, what we need to do is subtract 17, then divide it by 2. That's what we calculated here. That's what the inverse function needs to do. In other words, whatever goes into our inverse function, we need to first subtract 17 and then divide by 2. So that's what that means. And because our input into our function is always labeled by little x, that's why we've called it that here. So don't get confused by that. And also we need to label the domain and range of y inverse. Well, it's nice and easy because the domain of y inverse is equal to the range of y. So in this case, y inverse has domain R, and it also has range equal to the domain of y. So its range is also equal to R in this case. Okay, thanks very much for watching. Don't forget to check out the notes on this section and have a go at the exercises at the back. See you in the next video. Take care. Bye.